Thank you, Dr. Newman, for the introduction. Today I'm going to be speaking with you a little bit about my research involving Rhizoma peanut. Rhizoma peanut is a warm season perennial legume that is well adapted to the southern coastal plain region of the United States. In Florida, it has primarily been limited for use in hay production systems. However, it has been noted to have the potential to spread laterally into existing grass pastures when strip planted, which may actually provide an establishment method for us to begin to incorporate this legume into grazing systems in Florida. So first, I'd just like to tell you a little bit about what is strip planting. Strip planting is an establishment method in which sections of an existing Bahia grass pasture are extensively tilled. Those areas are then planted with Rhizoma peanut rhizomes, and that area is packed and allowed to establish for a period of time with the idea that the Rhizoma peanut will spread laterally into the grass portion of the pasture, eventually forming a mixed species pasture system. So why do we want to strip plant Rhizoma peanut? The first reason is that it would provide an increase in sward nutritive value compared to perennial grasses alone by adding the legume into the mixture. It would also decrease our dependence on nitrogen fertilizer. I'm sure many of you were here this morning and heard Dr. Lacefield speak about the fluctuating prices in nitrogen fertilizer over the last decade. And this is something that has really significantly impacted our producers in Florida because our summer systems are mainly based off of these warm season perennial grasses that require nitrogen fertilization. It would also decrease establishment costs compared to pure Rhizoma peanut stands. It's estimated that 1 acre of Rhizoma peanut costs about $550 per acre to establish, and ultimately this has limited the use of this crop to these more high-value systems as opposed to grazing systems. Finally, it would promote the formation of a long-term grass-legume mixture. By adding these two perennials into a mixture together, we would not have to come back every year and reestablish the area or replant. So currently, the only research that has been done with the strip planting approach with Rhizoma peanut is with Forage Rhizoma peanut. However, in recent years, the University of Florida has released several different genotypes of Rhizoma peanut that have yet to be evaluated. And one interesting aspect of these different genotypes is that each of them exhibits a range in growth habit. So this range in growth habit is significant because it could affect the way that these different cultivars spread into the grass pasture over time. And just to illustrate that, I wanted to show you a couple of pictures. The one on your left illustrates our more low-growing decumbent types of perennial peanut. This would be characteristic of the EcoTurf and Arblick varieties. The picture on the right illustrates a more intermediate to upright growth habit, which is characteristic of Flora-Graze, currently the most planted acreage in Florida, Arbrook, and two of the newer varieties, UF Peace and UF Tito. So based on these ideas, we developed two key questions for this research project, or two objectives. The first was, are various Rhizoma peanut genotypes able to establish faster and spread more readily when strip planted into Bahia grass sods? And the second was we wanted to evaluate whether or not we could utilize this area at all during the establishment year. So we wanted to look at the effect of different defoliation management regimes on that area during the establishment year. The experiment was conducted at the Beef Research Unit in Gainesville, Florida. We established the area by spraying 4 98-foot by 13-foot strips of Bahia grass in the fall of 2010 with glyphosate. Those strips were then clean-tilled and planted with the different Rhizoma peanut genotypes in March of 2011. And we fertilized the area according to soil test recommendations after the sign of first sprout emergence in April. The experiment consisted of 24 experimental units. This photo illustrates one of the experimental units. It consisted of a 13-foot wide Rhizoma peanut strip bordered by 2 3-foot areas of Bahia grass. And each plot consisted of 8 planted rows of Rhizoma peanut. Next, we'll move into our response variables that we measured in this experiment. The first was sprout emergence. We wanted to look at sprout emergence as a measure of the number of sprouts per unit area and that was recorded from the sign of first sprout emergence until 10 weeks after the initiation of emergence. We also wanted to quantify the amount of Bahia grass that could be utilized during the establishment year by either cutting or by grazing. This was done by harvesting 2 quadrats in each plot prior to the defoliation event to the target stubble height. Rhizoma peanut cover and frequency was estimated by placing a 6-foot by 1.5-foot frame at 2 marked locations within each plot. And at each location, we were able to estimate cover and frequency of occurrence in 4 of the 8 planted Rhizoma peanut rows. We also wanted to evaluate spread of the Rhizoma peanut into the Bahia grass at the end of the establishment year. This was done by running a transect down the middle of the plot and then pulling an additional transect perpendicular to that to the last Rhizoma peanut part that could be found in the Bahia grass strip. So next we'll move into our results. First we're going to look at our sprout emergence. There was an entry effect for sprout emergence such that the total mean sprout emergence was greatest for floor graze compared to all other entries. This was followed by ecoturf. However, ecoturf was not different from arblick, but tended to be greater than that of UFPs. We did not see any ground cover and frequency differences in our defoliation regimes, so there was no difference among the grazing versus cutting treatments. However, we did see a difference among our entries, with floor graze having a greater percentage cover compared to all other entries. This was followed by ecoturf. However, ecoturf was not different from that of arblick and UFPs. If we look at frequency of occurrence or the distribution of the Rhizoma peanut within the planted strip, floor graze had the greatest total frequency of occurrence. This was followed by ecoturf. Ecoturf was not different from arblick, however, it was greater than that observed for UFPs. If we look at our Rhizoma peanut spread, which we quantified at the end of the season prior to the last defoliation event, we saw that there was an entry by defoliation effect, with 3 of the 4 entries having reduced spread in the grazed pastures compared to the hayed treatments. The overall mean for the grazed pastures was a spread of 4 inches compared to a spread of 12 inches for the hayed plots. And as you can see in this graph, ecoturf and floor graze really emerged as 2 of the stronger cultivars in this experiment, with having the greatest spread, particularly for the hayed treatments. Finally, if we look at the Bahia grass herbage that was harvested across the season, there was a date by defoliation effect, with the hayed plots having a greater total herbage harvested compared to the grazed plots of around 1,000 pounds per acre. This was reversed in September, with the grazed plots having a greater total herbage harvested compared to the hayed plots. However, we did not see any differences among our treatments in October. In conclusion, floor graze and ecoturf had the greatest total sprout emergence compared to all other entries. This ultimately carried over into the rest of the season, where we saw greater cover, frequency, and spread of these entries into the Bahia grass during the establishment year. While we didn't see any defoliation differences on cover and frequency, we did see that the grazed plots tended to have a reduced amount of spread into Bahia grass compared to the hayed treatments. These results suggest that strip planting may be a viable option for establishing Rhizoma peanut grass associations in the southeastern United States. However, there does appear to be differences in some of the entries and the way that they respond using this strip planting approach, which ultimately will affect the recommendations that we can give producers on establishing these pastures through strip planting. And with that, I would like to take any questions.
Yes, during that, or in the strip raised area, the strip cultivated area, was there any weed problem? Did you have to treat for weeds there?
The question was, in the strip planted area, was there a weed problem, and did we have to treat for weeds in those areas? Yes, we did have to spray twice during the 2011 season for weeds. The first reason was for the encroachment of sedges in the area. we did that by spraying a Mazapic. We were able to control that pretty readily with that. And we sprayed that again in July of that year to control for the same weed problem.
Those weeds were not present in the non-tilled area, the non-strip area?
The question was whether or not the weeds were present in the non-tilled area, and they were not present in those areas. It was primarily just in that cultivated area that those arose. Okay, Dr. Hancock.
I was going to just ask what you thought about maybe putting in some sort of chemical suppression during the summer just to knock the haygrass back, and if you think that might help in any way, maybe using something like Select or something just to knock back the haygrass. Would that help in any way, you think?
Right, the question was whether or not we thought we should use a chemical control during the summer to help suppress the haygrass in the planted strip. Is that what you're asking? And yes, there has actually been some research done with that by one of my colleagues, Miguel Castillo, and he worked with spraying Select in the strip planted area and did see that it helped suppress Bahia grass in that area. So it probably would help promote the spread and establishment of peanut in the strip. Yes?
What were the reasons for releasing the two new cultivars? What are the traits that they have that they would release them on?
Okay. The question was, what were the reasons for the release of the two new cultivars? Are you speaking about the UF Peace and UF Tito types? Okay. The main traits for their release were, one was increased yield compared to the other entries that are currently available. They also exhibit a greater disease resistance compared to many of the other varieties, and they have been noted to spread and establish more aggressively than some of the other currently released varieties.
So how do you explain, compared to Forage, why didn't these spread as well?
Right, the question is, how do you explain the difference between Forage and UF Peace, and why did the UF Peace not perform as well? I think that one reason is that there has not been any grazing evaluation of UF Peace to date until this experiment. And while we may have seen spread rapidly without grazing pressure, we did see that it was affected more under grazing than the flora graze was. Yes? The question was, because Rhizoma peanut has a slow establishment time, what kind of management recommendation would we provide to a producer who is trying to use this approach? I think that depends on if the producer is interested in grazing the area during the establishment period or haying it. Based on these results, I think we can see that haying the area or harvesting the area every 28 days did not seem to affect the entries or the establishment as much as grazing. However, if a producer chose to graze that area, it would definitely be necessary to undergo some type of rotational management. We've seen in some previous studies that with continuous stocking, it was not feasible to maintain Rhizoma peanut in the strip with that management method, so it would definitely require rotational stocking.
We have time for one last question. No? Well, thank you very much.
Thank you.